See, this is going to be a preview of the process that we're going to explain now. First, we're going to predict the Z, so the number of electrons and protons, and then its electron configuration, which is below. Then we're going to identify some characteristics and then discuss the size of most common ion.
Okay, so hi, welcome to Chemistry by Maria Lucia and Victoria. So first we're going to start with J. So we have to predict C and electron configuration of the atom. So since we know that C is 37 because here we have 36 and plus 1.
36.
Here we have 36 and plus 1 is
going to be 37.
So in order to do the electron configuration, we used AR, that is 18, and then we expanded, and 4s2, 3d10, 46, 5s1. So it's obviously an element that is in group 1, period 5. It has a very big size because it has low effective nuclear charge, as you can see here.
Since it's in the first group, because effective nuclear charge increases as it goes to the right, and effective nuclear charge decreases as it goes down, and it's in group 1 and period 5.
Remember that effective nuclear charge depends on the protons that it has and how much the protons are taking the shells and putting them together. Since this is a new shell because it's in group 1 and it only has 1 electron, obviously the effective nuclear charge is not strong enough and it will be a very big element.
Exactly.
So obviously it will be a cation when it goes and has a
Because it has
compound with
plus
another,
1.
Yeah, with a non-metal, it will be a cation. And yeah, that's practically it. Now Maria Lucia is going to explain
K.
Yeah. Okay, so good afternoon. My name is Maria, and today I'm going to explain to you the element K. So first, we predicted that Z is going to be 17 because, as you can see, we have K is 1 squared to the left of 18. So if you subtract 18 minus 1, which is the electron, it's going to give you 17. Okay, its electron configuration is going to be this one. If you add this up, it's going to be equal to 17. Then the second one, some characteristics we encountered was that K, its size is going to be small and it's going to have a high effective nuclear charge because, as you can see in the periodic table, K is in group 7 and period 3, which means that its effective nuclear charge is greater and its size is small. It's going to shells. And then lastly is size of most common ion. It's in the 7th group. It's going to be an ion of -1. And that's it.
Yeah, and now we're going to explain
Hope you learned.
the compound JK, and I'm not even kidding when I'm gonna say this. Okay, so here we have J and K separately. As we said before, this has a very low effective nuclear charge, it's big, and K has a very good effective nuclear charge. So,
But it's small.
yeah, it's small. So when they come together, this is giving 1 electron to this, and this is taking 1 electron. It's going to have a very high effective nuclear charge because it will have a shell that is full and it will have more electrons than protons. And in the other hand, K is going to have 1 electron more, so the effective nuclear charge is going to decrease, but it will have a full shell, so it's going to be happy.
Okay, beautiful. Thank you, Victoria.
You're welcome.